Hi, I'm Dr. Kamakshaya. This video cast, I'm going to talk about a free uh, software application called, FreeSEM. FreeSEM is a desktop application right now available for all Windows operating system. This is primarily intended for certain family of analysis like EFA, CFA. In CFA, it supports CBSEM and PLSEM, and there is one more SEM, uh, a special SEM technique called MetaSEM. So all these CFA techniques will be available together with EFA and other etc. will be available in the same application. So I assume that you know the basics of EFA and CFA in this videocast, because if you are watching this videocast, I'm sure you would be searching for an application meant for either CBSEM or PLSEM or maybe MetaSEM sort of. So where do you find this application? So you had to go to my GitHub portal, excuse me, that is github.com/codingfix, and there if you go to the repositories, you will find something like FreeSEM here. Right now there are two releases, two versions. The current version is 2.0.0, something like that. So all the the updates along with the bug fixes etc. all documented here. So what you need to do is you just have to choose, select this FreeSEM setup v2.0.0. That is very, very important. Okay, already installed this in my, just have to download this and install as an admin. And after this is just a plain Python application. You don't need to worry. You don't even need to install Python in your computer. Better to have it. So after you install it, it looks like this. So there is nothing so special about installation. You just have to download the file, exe file. Right click, run as administrator. Next. Last, the installation window will prompt you. Do you like to run the application? You just select, run the application. After that, you will find I have chosen an option, desktop link while instance, so it is available on my desktop. So these are all, very basic things. I think every one of us are aware of how to install the softwares, and I just wanted to. At times there are people, who belongs to Linux and OpenBSD kind of operating systems, and they'll not be familiar about how to install the applications in Windows operating system. But majority of the users of Windows chooses a Windows platform for operating systems. Okay, so when you open the application, it just looks like this, a white color preview panel. This is actually a canvas where you will build, you'll draw the figures just like you do it in MS and I think Onyx. Long back I used a software application. It is actually a Java based software. This is Python based for so what you need to do, so you have the freedom to either design, I already have one saved here. If you go to the file, you are the new project, open project, save project, something like that. So how do you start? In structural equation modeling, first usually if you are a programmer, we don't draw the figure. We start writing the code, and the code creates the figure. But somewhere in the history, IBM MOS has brought up drawing activity into this. So you'll be having a paintbrush kind of thing where. But here, this is not a brush. I don't have the paint here, so this is not a paintbrush. This is just a plain canvas where we are just going to attach some shapes by clicking, with the help of a few mouse clicks. So how are you going to do that? So if you want to add latent, variable, this is actually, the structural equation modeling in open source communities call it as latent variable analysis, LAV, in R and Python. So there are latent variables. There are two types of latent variables. I assume that you know the basics. One is exogenous, the other one is endogenous. In shortcut, endogenous is something which takes the arrow, and exogenous is something which gives the arrow. Gives the arrow means it is fitted with the help of an observed or manifest variables, where the arrow goes to the manifest variable from the circle. Circle is assumed to be a latent variable. Okay, an endogenous variable is a variable which takes the arrow, but it doesn't give arrow to any other variable, something like that. This is a shortcut understanding, but in layman words. So how do you add? Add latent. This is the button, and now you have to. So like this, you can click. Keep clicking like that. I think you need to click once again. So I have three latent variables here, and how I determine my relationships. I try to connect L1 to N2 first. So for that you got add path. You just have to press L1 first, and then it is a left mouse key. You'll get an arrow. And then I want to connect L1 to L3, right? Click on L1, click on L3. Okay, you have to once again add and then click on L3 and then L2. So take care that you will not be clicking on this. If you double click this text widget, you will be having an opportunity to. You can change these names. That is what you can just write it as age. So I mean, it cannot be age, something like that. But like that you can also. Right now it is L2, right? I don't want to. Now, if you want to add manifest variables or maybe observed variables, add observed. Then you will be having add observed and add observed. I want to have two. I want to have two for L2. I want to have two for L3 and L1 and 2 for L. Now, usually how it happens, it will take the path, arrow from latent to the observed. First, I will start with L1 to L6, and then again I add path L1 to L7, add path L2 to L8, L2 to add path to L9, add path L4. So if you click somewhere in the, because it has right click context, so that's why the moment you finish a particular task, it comes to normal condition. So you don't remember your action, which means you can't keep clicking for the same shape. So because you got right click context here. Okay, now I need to add residence variances. Actually, this is introduced by MS. We don't have. It will ask you like, where do you like to add this residence variance? Top, I want residual variance. Top, I want this here. Left, I want. So I choose left here, and then all these are linear equations. This residual variances, path arrows, and everything is wherever you have an arrow, it is actually a relation. Residual, again I want to go for, this time I want right side, okay, and here I want right side. Okay, fine. So this is my diagram. Now remember your names. Names are very, very important. I have three latent variables, L1, L2, L3, which we are not going to have in our input data, but these manifest variables, we need to supply the data. So like x4, x5 till x. So you have to go to the next tab, import data, and here I'm going to supply the data. This is the home directory of the FreeSEM. If you go inside internal, you will find a data. I already have some simulated data set which I'm going to fit. This is just a custom made kind of, which mimics like a real world data kind of thing. You have so many other options which I'm not going to talk right now. You can paste CSV here, and you can create a new data, some sort of. And the last one, green button, is entirely a different, a technique called metaset. Okay, right now I'm going to perform the EFA. And after that, I'll show you in my consecutive videos. I'll show you how to perform CVSM, PLSM, etc., etc. Now you have to go to the fit. See here, this is where you select the technique. Right now, I'm selecting EFA. I don't need the syntax for EFA, because EFA is straightforward. For CFA I need syntax because this is a Python. You don't need to write any syntax. You will create, the application will write syntax for you. That is why it is low code, no code kind of. Now you just have to press this button, bit fit model. So the automatic is Kaiser criterion. I don't want automatic. I just, because I'm afraid this will fit into one single factor, which is called generic, kind of single factor model or one factor model, whatever. I want two factors. You can also increase your number of factors here. If you assume that there are three, so we have three. In my diagram, I have three latent variables, so I assume three factors. You can select extraction method. You can also select rotation method here. I'll just keep default properties as it is and press OK. The moment you press OK, it will compute all. So what is in summary? Number of observations 50, that is your data set. Number of variables 10. Number of factors 3. Yeah, KMO is 0.0000. That is unacceptable. It should be minimum 0.5 partial correlations. And then Bartlett chi-square test, oh my god, it's very huge. The p-value is 0, which means it is very, very significant, right? Total variance explained is okay. I think it's not 0, I'm happy. And average communality is .037, which means it's percentage in ratio. So now let's go to the factor loadings. So you can look at the first factor, all of them are negative except one, and second factor, all of them negative except one, and the third factor, yes, of course, there are positive loadings, but I don't find such a strong loadings here. This is anyway, synthetic simulated data set. So you just have to name, if you know your data particularly, like here I have some sort of meaningless data, which means x1, x2, x6, x7, x8. What do you mean x is just unknown thing? This is just a demonstration which I don't like to be very serious about. In case if you don't know how to interpret your the estimates, you just export them. Maybe you can export that into a CSV file and then hand over this data set and loadings to your generative AI, LLMs or ChatGPT, whatever it is. That will help you how to interpret. If you have valid names, okay, it will also help you how to, this LLMs will help you how to name these factors, something like that. Now communalities, you have communality as well as uniqueness. So you need to read the theory. What is communality? Communality means belongingness of a given variable to the model, and uniqueness is how unique that particular variable in contributing to the model, or maybe fitness. So variance explained. This is the table. Factor 1 seems to be reasonable, while the cumulative variance for factor 1 is 37%, and it doesn't change much for factor 2 and factor 3 either. So the change is not that significant. And now coming to the scree plot and other factor map. You got these two plots here. As you can see, this is actually a single factor solution. So I have fitted 3. 3 is also okay because elbow takes the shape at third. But maximum you can go to the 2, but not 1 is the best solution. So I cannot. That is why my factor loadings are meaningless. Maybe you go back and then you once again take. This time you just take automatic Kaiser, and now you see you'll get some. All of them are negative. Communality. Let's go for the variance. The same variance. Okay. Fine. So this how. This is how you can perform. So now what you can do is you can just download this results in reports, export them as reports, and then use them to move further for confirmative factor analysis, something etc. So that's for this video. I would like to talk about EFA using FreeSEM, and I'll be talking about CBSEM in my next video. Thanks for watching this video. Stay tuned for the new content. Bye bye for now.